Right. In today's session, we can try something different. Actually, a new section for us. Let's try this problem regarding a factor theorem. So, a very simple idea, right? I think you can understand that better through a graph. For example, let's say, let me draw a graph like this. So, right? So, as you can see, how many x-intercepts are there? So clearly two x-intercepts, this point and this one, right? Now, therefore, we can use those two x-intercepts carefully like this. Let's say this x-intercept equals to 2 and this one 4, which means, right? So let's suppose the function is g of x, y equals g of x. Now, y value equals to 0 at this point and also at this point. So that's the idea, right? So these are x-intercepts. Hence, we can write something like this. Y equals to 0 when x equals to 2. And also, y equals to 0 when x equals to 4. So how would you get a 0 for y? Yeah. To get a 0, I think y should have factors like this. X minus 2 and x minus 4. There can be other parts as well, but mainly these two factors should be inside y or inside g of x, same thing, right? Because when I equal this to 0 to compute x-intercepts, to compute x values, if I equal this to 0, either x minus 2 equals to 0 or x minus 4 equals to 0. From that, you can solve these two, x equals to 2 or x equals to 4. Can you understand that? So x-intercepts and factors, there is a relationship. So x equals 2 is a x-intercept. Here, this one x equals 2 is a x-intercept, right? Therefore, x minus 2 is a factor. X minus 2 should be inside that function. Because otherwise, how would you get 2 as your x-intercept, right? That factor should be there. So that's the idea. And also you can go the other way as well. Whenever you have a factor like x minus 2, then we can claim that x equals to, say, x-intercept. Yeah, sometimes we use different terms, roots, x-intercepts, like that. But that's the idea. So we can express that idea like this. So the polynomial f of x, right, just a function, right? Not going to explain too much about polynomials right now, right? Expression like this is how we write that. Don't need to worry too much about this right now, right? That kind of something like this, x to the power of 4 plus 4x cubed plus 2x squared, something like that. plus 5x plus 3. That's an example for a polynomial like that. So now the idea is simple. If the polynomial f of x has x minus c as a factor, if and only, which means you can go both ways, this direction or this direction, right? If x minus c is a factor, if x minus c is a factor, which means then let's suppose like x minus 2, right? If x minus 2 is a factor, which means when x equals to 2, when x equals to 2, y value equals to 0. In other words, when x equals to 2, f of x equals to 0. So we express that this whole thing using function notation, f of 2 equals to 0. So that's the idea. If x minus 2 is a factor, f of 2 equals to 0. That's all we need actually. And also the other direction. If f of 2 equals to 0, then x minus 2 is a factor. If the function value equals to 0, when x equals to 2, we know for sure x minus 2 should be inside that function as a factor. That's why I explained that through a graph. So you can always use that graph to understand the concept. X minus 2 is a factor like that. So let's use this, right, for our problem. Right? Now think through a graph. I think that's much better. Right? Don't need to remember a lot. What can you say about this situation? The function f is defined by a polynomial, right? If x minus 1 is a factor of f, which means, so this f of x function, x minus 1 is a factor, which means x minus 1 will be inside f of x. Like this, x minus 1. Of course, there will be other terms. Like this. That's not a problem for us. Now, so far, we know that x minus 1 is a factor. Right? If you want to, let me put y as well. Right? Y equals to this. Then, now if I draw this curve, what will happen? Now, when will you get y equals 0? Right? Y equals 0. I mean, this curve, f of x curve, will intersect x-axis at 1 point, maybe 2 points. We don't know that. Right? What are those points? How would you compute those points? That's the question. Right? So it could be like this. So something like this. 2x intercepts. But we don't know that. But we know that x minus 1 is a factor. Therefore, what will happen? What will happen if x equals to, if this part, if x minus 1, that part equals to 0, doesn't really matter what's inside this. If x minus 1 equals to 0, then what's the y value? Y value, x minus 1 times this part. But if x equals to 1, if x minus 1 equals to 0, then this part equals to 0. Hence, the entire function will equal to 0. Because it doesn't really matter what's the value that we have inside this bracket. If x minus 1 equals to 0, 0 times any quantity equals to 0. Hence, y equals to 0. That's the idea. Which means if x minus 1 equals to 0, I can move that 1 to the other side. If x equals to 1, then y equals to 0. In other words, if x equals to 1, the function value f of 1, right, equals to 0. That's the idea, right? So in other words, I can draw the graph. This is not the exact graph, we can't draw that. But we know for sure when x equals to 1, y equals to 0, which means graph should go through this point. Doesn't really matter what the shape is, we don't know that. Could be like this or like this, right? We know for sure that this point, that's the x-intercept, right? Now we can solve our problem using this concept.